Okay, and so that was what you did in part A is a good, very good presentation of the way you solved the problem, the challenge problem I gave you. But I decided that this might be a fun movie project because there's a different pattern here, and I'm interested to see if you can see the other pattern and talk about why there's an alternate pattern here. See if you can find it.
Well, is it gonna relate all the sides?
Yeah, it is a pattern that does relate all of the sides together.
So we could look at the sum, maybe, of what the sides are.
Okay.
The sum of the sides would be, well, for the 3, 4, 5, it would be 12. And then here, it would be 30.
All right.
So, doesn't seem to have much in common.
Okay. Keep looking. There's a very interesting pattern, but I'm just curious, what do you notice about the numbers or anything like that? I'm interested to hear your thoughts on this as much as I am on if you find the pattern.
The longer leg and the hypotenuse, they're always in the same ratio. Like, the longer leg's always just one smaller than the hypotenuse.
Yeah, but let's be careful. That's not the same ratio. The ratio here would be 5 to 4.
Yeah,
that's not 13 to 12.
Yeah.
Okay, they differ by 1, you mean?
Yeah, they differ by 1.
That's an important thing. They don't have the same ratio, but they differ by 1. Okay?
And it looks like they're getting larger faster than the short leg.
Ah, that's interesting. Very interesting. You notice that the short leg always increases by 2.
Yeah.
But the longer legs get bigger faster. And what else did you notice about how the longer legs get bigger faster?
Well, you start by adding by 8, and then you increase what you're adding by 4.
By 4 every time for both of them.
Yeah.
So they get bigger faster in exactly the same way.
Yeah.
Okay, so that's interesting.
So that relates those two sides together.
Right. But the third side, the short side, seems to be different.
Yeah.
Okay? So see if you can see anything about any patterns. Any patterns on how all 3 legs relate to each other, besides the Pythagorean theorem.
Well, would our difference of squares trick work for any pair of these sides? Probably not.
Well, look through your difference of squares. What happened when you did the difference of squares?
So when I paired these two, like when I paired the long leg and the hypotenuse, I always got 1 times the square of this.
Interesting. What does that mean in the triangles?
Well, it's the Pythagorean theorem, but it's sort of flipped around.
Yeah.
So, well, I used these 2 legs.
Right.
And I got the square of this part.
How?
Well, the long leg, the hypotenuse minus the long leg, times the hypotenuse plus the short leg, and the long leg. This minus this times this plus this. That's what I did.
Yeah.
And it always equaled 1 times that. 1 times the square of that.
Okay, so what does that mean in terms of the triangles?
So that holds true for all of these.
Yes, it does. So what does that mean in terms of the triangles? There's a very simple pattern in the triangles.
Well, the sum of these sides is the square of what this is.
5 plus 4 is?
9.
Which is?
3 squared.
13 plus 12 is,
25.
which is
5 squared.
24 plus 20, 25 plus 24 is,
49.
which is,
7 squared.
so let's move on.